Good evening, students. Welcome back for another lecture on coordination compounds. What we were talking with you that writing the formulas of the coordination compounds and
Yes, sir.
IUPAC naming of the coordination compounds. This is very important. How do we name these compounds, students? As I said, when the number of compounds becomes very large, students, there has to be a scheme, there has to be rules which we must obey in order to name these compounds. And these names, these rules are given by IUPAC students. And last time we have told you how to write the formula of mononuclear coordination compounds.
Yes, sir.
For example, students, what we said, you already know central atom is listed first. Ligands are then listed in alphabetical order. The placement of ligand in the list does not depend on charge. Polydentate ligands are also listed alphabetically, and formula of entire coordination entity, whether charged or not, is enclosed in square brackets. When ligands are polyatomic, their formulas are enclosed in parentheses. There should be no space between ligands and metal. Whether the formula of charge coordinate is to be written without that of counter ion, the charge indicated in the bracket as a, is indicated as a right superscript with the number before the sign. The charge of the cation, students, what we said, charge of the cation must be equal to charge of the anion. These are some of the
Nine.
rules on the basis of which students we said ki we can write the formulas of the compound, students. We can write the formulas of the compound. I will take only one or two cases because we will go further to the nomenclature.
Yes, sir.
Give IUPAC.
Sir, in this, please explain the E part.
Okay.
Tetracarbonyl
All right.
nickel.
Wait for a second.
Yes, sir.
Okay. First, what we are saying, students, for example, if I take E part, student, E part is tetracarbonyl nickel 0. Okay, first you tell me what is the rule which we use? What rule we have told you? What should be written first in the coordination compound?
Central metal atom.
That is that here nickel.
Nickel. Nickel.
Now he is saying tetracarbonyl. What is the formula of CO ligand? CO is a ligand.
Yes,
CO
sir.
is the ligand, student. ठीक है? We
Yes,
know
sir.
CO is a ligand. So how many are there? This is a monoatom,
Try.
or it is having more than one atom.
So CO3, whole 3.
CO only, I'm saying it is not CO3, it is carbonyl CO.
CO and whole 3 because it is tri.
So
No, tetra, whole 4.
CO tetra means 4.
4.
So NiCO4, students. Now CO, does it has any charge? Tell me.
No, sir.
No
No.
charge. So this is a neutral ligand, student. Neutral ligand. Charge is 0. Therefore, student, this is the formula of the compound. Because
Okay.
then in this case, what is happening? There is no charge on this. Nickel is in zero oxidation state. That is why it is written nickel 0, students. So this is
Okay.
the way we write. These are, we will be studying the carbon monoxide forming complex compounds with the metal ion, students. We will
Okay.
show you what type of bonding is there.
Okay, sir.
This is a very stable compound and is very important compound of nickel. It's very stable. Nickel, tetracarbonyl nickel, it is being used also in metallurgical process for the refining of the nickel. Okay, so what we have tried to show you, student, that we can write the formula and of any of these. So such compounds are important. For example, this is important. This question was given. Dichlorido bis ethane 1,2 diamine cobalt 3. But how will you write this? You have, what is the central atom here?
Cobalt.
Cobalt is the central atom. That is the first which is coming. Now, how many ligands are there? Chlorido,
Chlorido and En. two ligands.
En, En how many? This.
Two.
This means there are two of this.
Two. Yes, sir.
So either we will write the complete formula CH2 NH2 or we will write ENE, student ENE. Now in this case what will happen then? Tell me. The first one E comes first or C comes first?
C.
C comes first alphabetically. Alpha. Okay,
This will be cobalt.
alphabetically. The rules we have to learn alphabetical arrangement. The rules are, it is not easy to remember all the rules that, but I said ki when we will solve lot of questions, then practice will be there and we will be able to have a memory of those. So students, you are saying cobalt, then what we should write? C,
Cl2.
Cl2. There is no space. Then what we
Yes, sir.
should write?
En whole 2.
E and whole two. Okay. The dichlorodo, chlorido, because why chlorido? Because it is negatively charged. Anions are ending with IDO. Tetra, where is that? Dichlorido bis ethane, cobalt 3. Now there is an ion, counter ion given.
No, sir.
So what should be the charge on this now? That is the question. Cobalt oxidation number is given. How much? 1,
3.
2, 3. Now tell me, if cobalt is in 3 oxidation state, student, what should be the charge on this? This is the problem here. We have to calculate. This is where students do mistake. Student, okay, you have 30 seconds. If this is X student and what is Cl plus
It will be minus 2.
2 into minus 1.
Minus 1.
What is ethylene diamine?
0.
0. So what charge you want, student? What charge you want for the cobalt?
3 plus 3.
Plus 3. Then what should
Okay.
be? Uh,
X minus 2. This is
Cobalt is in plus 3 oxidation state. It is saying cobalt is in plus 3 oxidation state. If I put this plus 3, I should not put it here. Cobalt is in plus 3. Then what is happening? Minus 2. What is it? The answer coming?
1.
Plus 1. Okay.
Okay.
This is the catch here. This is the difficult part. That is the where
Uh,
students will do a lot of mistakes, students. So what should be the charge, student? Then the this x is plus 3, this is minus 2, and this is 0. Then plus 3 minus 2, then it should be plus 1. Answers will be plus 1. Here
okay.
students will do mistake. That is important, student. I hope we have to, as I said, we have to try and work it out, student. There is no short.
Yes, sir.
If I will try to without
Sir, please explain this balancing part in with the help of a counter ion also, if a counter ion is present.
we are going to have so many cases. Wait and see. So many examples will be coming. Counter ions. We have already given you so many examples of this. All this. What was this? These ones. If I take this one. What is this? Potassium.
Trioxylato aluminate.
Okay. This is which part? C part. What is the central atom here?
It is aluminium.
Aluminium is the central Al, and here you have the counter ion is potassium,
Potassium.
which is a positive ion. This is an anionic. Potassium You know what is potassium? It is a cation, and this will be an ionic part in the complex because the first one is the cationic part. Now, aluminium, we are saying aluminium students in this case. So, what is the, where is it? Potassium trioxalato aluminate means when I am using ATE, it is very clear. ATE means it is an anionic complex,
Anionic
anionic
ligand.
complex.
Anionic
Now,
complex.
oxalato, what is the formula? CO minus, CO minus. How will I use it? OX.
OX.
What is the charge on one oxalate?
One is -2.
One oxalate is minus.
2.
Okay. So students, we have aluminium. What is the oxidation state of aluminium given?
3.
3
Plus
plus
3.
3. Aluminium is plus 3. And you have oxalato. How many? 3.
3.
That's all?
Yes, sir.
Anything else?
No, sir.
Okay. Aluminium oxalato, or I may write it AlC2O4 students 3. Okay? You can write this or this. There's no problem. Both are acceptable. Now I will return this part. Okay?
Yes, sir.
What I want is student what I want is that this is how much. If it is X student, if it is X, then how much is this? Plus
-6
3 into
to
minus 2.
-2.
So this is coming X minus 6. X minus
Yes, sir.
6. But the question is aluminum, what is the charge plus 3? Okay?
Yes, sir.
So how will this X is coming to be, what I say, X minus 6 equal to 0, then X is coming to be plus 6.
+6.
So if X is coming to be plus 6 student, how will I get plus 6 if how many potassium should be there? Because basically you are saying this is potassium trioxalato aluminate 3 because this is my anionic part and this is my cationic part. Cationic part. So how many should I put in this case so that I get the plus 3 oxidation state, plus 3 oxidation state of aluminium, plus 3 oxidation. Or in other words, if you are saying this is plus 3 minus 6, how much is left? Tell me.
-3.
Minus 3. Now this minus 3 should be balanced by what?
Potassium.
Potassium. This
3
has to be
potassium.
balanced because the overall compound is neutral. So how many, what
Okay.
is the valency of potassium?
+1.
Plus 1. So how many should be, I make it to make it 0 student?
3.
3.
3.
So then that is why
Okay.
I say 3K and this. So what will be the answer coming student? K3 Al
AlOX whole 3.
C2O4 3.
Yes, sir.
This is the formula of the compound.
Okay.
Actually, we have to work and we have to think, and slowly we will learn more about it. And we have to see that the total charge has to be balanced. If potassium was not there, then it would have been there will be some charge on that which will be what, how much? 3 minus. 3 minus will be there. Then 3 minus will mean aluminium oxidation state is plus 3.
+3.
So you work left from answer to the back or from back to the answer.
Yes,
The
sir.
total charge, as we said in the rules, should be balanced. What we said in the last rule, okay, you can see the statement why it is given. The charge of the cation is balanced by charge of the anion.
Anion.
That is why, because the whole compound, when I write this, I am not writing any charge on this student. It is neutral. It is neutral.
Okay.
Therefore, students, what is required is that we have to practice, practice, and practice, students. So we have to see that there will be cations and there will be anions, students. Anions and cations both will be there in the questions. We have to be careful in answering the question that how much charge we should put, student, If I take this case, student, for example, okay, I give you 1 minute, you can try, 1 minute, you can try, because I will also try.
Sir, which one? Last one?
Yes.
Okay.
How will we answer this question, student? Iron,
Iron 3 hexacyanide.
iron is in 3. Iron 3 means this is a cation, student.
Yes, sir.
And this is an anion because
Anion.
ferrate, ferrate means what? This is an anion, students. This is iron. This is in 2 plus oxidation state. How many hexacyano? There are 6 Cn minus.
6 Cn minus.
So what will be the result of this, student? You have FeCN6.
Cn whole 6.
That means iron is plus 2. Iron is plus 2. And how much is this? 1 Cn, charge of Cn is minus 1.
Minus 1.
6 into minus 1. How much it is
Minus 1.
coming?
Plus 2 minus 6 minus 4.
Minus 4, students. So that means this is having minus 4, students. So how will we balance minus 4, students?
It is plus 3 and it is minus 4.
And this iron is in plus 3. The iron is 3 plus, student.
Sir, we can multiply like Fe plus 3 we can multiply by
Yes,
4.
yes, you can multiply. So how much should I multiply this by 4? It becomes
4
plus
and
12. And how much should I multiply 3?
3. So
Then
it
what will be
becomes
the
my
result of
answer.
these students? Fe4
4
and
FeCN whole 6 3.
whole 3.
Yes, sir.
You can see that what type of answer we are getting.
Yes.
Uh,
Okay.
But the charges are important. We have to balance the charges. Without that, how will we get the answer, student? So we have to see what charges we are balancing. Okay, these are some of the questions, students, which we have tried to uh, give in these cases, and we have tried to answer the questions. Now we can move further. We will again do more questions on it. It is not over. It is not over, because I will be solving more questions on this. We are going to have a question, more questions. One question is how to write the
Formula.
formula. Okay, first thing we
Yes, sir.
did, how to write the formula. And you have seen what difficulty we are facing, because we have to balance the charges. The
Charges.
charge of
Yes,
the
sir.
cation and charge of anion must be balanced by the end. And oxidation numbers are given, and you have seen cationic part is there, anionic part is there. Cation is always written first, then anion is written second. Even in chemistry, what you do, sodium chloride, NaCl, the first is
Yes,
the
sir.
cationic part. And when I write NaCl, the charges are balanced. Do I write
Yes, sir.
NaCl plus or minus? Nothing.
No, sir.
So that is how we create the formulas of the compound. So,
Yes, sir.
so how to write the formula, students? So this is the first thing we have done. Now we will be doing more practice on this. It is not over, as I said, because this is important for the paper. There is some confusion still existing, because unless we solve a lot of questions, we will have difficulty. But let us introduce to you second part of it. In every exam, one question is there from nomenclature. It is clear, and we should learn it.
Yes, sir.
Nomenclature. I am saying IUPAC nomenclature. Okay? This is given by IUPAC. So if we don't do the rules properly, then there will be great difficulty. Great difficulty. So how to write the formula? Now, naming of the mononuclear coordination compounds. How will we name, student? How will we name the nuclear coordination compounds. How will we name the mononuclear coordination compounds?
Okay.
And again, I have to give the rules. Again, I have to mention the rules. Student rules. I said ki they are written in the book. I have taken it from your NCRT book. We can read it, but after reading first time, we have no answer. We have to learn it. And we will learn slowly and slowly as we will do more and more questions, students. So first rule, when naming the coordination compound, cation is named first in both positively and negatively charged coordination entities. First thing, I hope you understand. In every coordination entity, student, in every coordination entity, there are two things. What are the two things? One is the cationic part and other is the anionic part.
Anionic part.
Which will be written first? Cation. As
Cation.
I have shown you, but the names which we gave you, potassium, when I gave the name, student, it was clear what we are saying. In either potassium tetracyanidoniculate. So niculate means it is an anionic part. This is a cationic
Anionic
part.
part.
So
Yes, sir.
wherever cation is present, where it is anionic, then cation has to be given first. You will see potassium, they are cationic parts wherever they are. So this is a cationic part, iron 3. So it is written first. Okay, all right. First part is clear. The ligands are named in alphabetically order before the name of the central atom or ion. The ligands will be named the ligands will be named before the central atom, before the central
Atom.
atom or ion. This is the reverse of the what we write. First, when I write the formula, the central metal was written first,
First. Yes,
ligands
sir.
were written second. But here ligands first, and then what will happen? They will be again alpha alphabetically alphabetical order will be followed, student. Always we follow the alphabetical order because it is easier. Let me go back and see what we said. What we said, this is a name, this is a name of student. If this is your tetra, what is the name of this? We have just given tetracarbonyl nickel. Where is the formula? This, when I will give ask the write the name of this, what I have to do, these are ligands are written before, are written before the metal.
Okay.
Ligands are written before the metal, students.
Metals.
So if there is more than one type, then alphabetically order will be used. Alphabetical order will be used. That also we will, as we will solve questions, we will learn more about it. So ligands will are prefix. So see, for organic chemistry, we gave you the IUPAC naming. There also I gave you the rules, and students always find difficult. And we also know that unless I solve a lot of questions, students, then the problem will continue because there are so many rules and for different functional groups, priority wise and all that. So here also we are giving similar type of rules. So there one question always there. The ligands are named in alphabetical before the name of and this procedure is reversed from writing formula. Okay. Third point, names of the anionic ligands end in O. This is important point. Anionic ligands. I am saying there are two types. I will give a list of this now. Anionic ligands, students. And there are neutral ligands. Tell me. And there
Yes,
could
sir.
be cationic ligands also. They are very less, because cations will not lose electron. But if you have a plus and another atom which has lone pair of electron, it may do it. For example, if I write something like this, see what is happening. This is a positive part. NH2 hydrazine has gained one proton, hydrazonium ion. NH2
Yes,
NH2
sir.
is hydrazine. Now here there is still one nitrogen which has a lone pair of electron. What is this? This is hydrazine. See, hydrazine, if it gains one proton, then what will happen? Because one part is basic, it can form this ion. So there could be certain such situations, students, such situation. And even there could be some radicals like methyl radical. 1 electrons. So ligands could be of different type, but mostly our course will be concerned mainly with the negative and neutral ligands. ठीक है?
Okay. Okay.
Anionic or neutral ligands. Our two main thing will be this. The special cases we don't need to go for that. Anionic ligands will be there and neutral ligands will be there. Student, anionic ligands we will have to end in O. When I say Cl minus student, Br minus student, what they are saying?
Chlorido.
Chlorido. Even chloro has been used. CHO, I mean chloro, we have to see the spelling. Earlier chloro was used, but now they are saying chlorido. Even chloro has been used. Bromido, like this, the negative ligands have to end in O. Students end in O. You are saying nitrito, nitrito like this, NO2, NO2 nitrito, NO2 minus, nitrito. O is the coming for the end. Cn minus, what you said? Cyanido. It was cyano earlier. So you are using O letter last in O. ठीक है, name of and in O. Those of neutral and cationic ligands are same. Neutral ligands, or what he is saying, cationic. He has used the word cationic. That's why I gave you example. ठीक है? If he will not use it cationic, I may not have given. NCERT book, you have to read it each and every word, because he mentions it. He has not given any example of that, but he says neutral or cationic, because he must be also taking it from some source, IUPSC, from IUPSC naming. If I go back to the IUPSC literature, I can get this list. ठीक है? If they are revising after some year, that also changes come. So neutral and cationic ligands are same, but there are some special names which we must learn, students. Special names that we have to learn. This water will come a lot. Tell me what is the name of water which we are giving?
Aqua. Aqua.
And NH3 will come a lot.
Amine.
What is that spelling now? Spelling
AMMINE.
Okay, that amine was 1M. And we can do a mistake here. If I will write single M, it will be wrong in the paper, students. And students will do that. Unless I mention, you point out, you will also do that. I was also writing AMINE, but all of a sudden, when I read it very carefully, see the point, this is double M. There is some confusion, because I am used to amine.
Yes, sir.
So that amines chapter in the organic chemistry, they say amines AMINE has coded. So my mind works like that. But I have to see, students, this was the point I gave you in one of the medical exam. They asked the spelling. So students were having great confusion. Carbonyl. CO is carbonyl, student. CO is, what is the name of CO? It is
Carbonyl.
a neutral ligand.
Yes, sir.
Carbonyl and NO, nitrosyl, important. They are going to be used, student. What are going to be used? Nitrosyl. We must learn them. Learning has to be there, students. So these are placed within enclosing marks when written in the formula of the coordination entity. There is more than one atom, you can see. So how will we write parenthesis? How will you write CO? Like this?
Yes, sir.
2O like this. Only those which are mono, single, we are writing like that. So this is a point for the ligand, student, which is my rule number 3. Coming to rule number 4, students. Here we are talking of how many number of the ligands are there. We are used to, this is a prefix always. If I have 2 ligands, di, 3, tri, tetra, penta, hexa, that familiar, we are familiar with.
Yes, sir. Yes, sir.
Same, indicate the number, that will be the prefix before. But if the ligand has a numerical ethylene diamine, you are saying ethylene diamine, there is already di in this.
Yes, sir.
So then I use bis, tris,
Okay.
tetra, kis. Bis, tris, tetrakis are used the ligand to which they refer being placed, students,
Okay.
in the parenthesis. So
Okay.
here, for example, you can see there's a, this is triphosphine. It is there is a tri already there in the, when I write student P, this is PH3. What is that? Triphosphine for
Trifosfin.
phosphorus triphosphine.
Yes, sir.
Then tri is already there. So what I will use then? Then I triphenyl phosphine. This is my triphenyl phosphine ligand, student, and there is already tri in this. So I will put it in bracket and put, what is that? Bis, tris, tetrakis,
Yes, sir.
pentakis, like that. Hexakis. So this is a way to remember them. So what is the IUPAC name of this? We are saying these are 2Cl, and this is di bis because there is inside it. So that is our dichlorido alphabetically it will come first. Anionic ligand, and bis triphenyl phosphine, and there is no negative charge here. There is no negative charge. It is not an anionic ligand. It is not an anionic ligand. So nickel 2. Okay. Further, student, this was point 4. Any doubt here?
No, sir.
I will give a list. I am going to give a list also. Wait for some. Further, I am saying, student, oxidation state of metal in cation or anion or neutral coordination number is indicated by Roman numeral. Why did we spend time in finding the oxidation number? Because oxidation number was used in writing the formula also.
Yes, sir.
And again, I have to write the oxidation number of the metal. And you know what Werner's theory was? What is the primary valency?
It is the oxidation number.
Oxidation number of the metal.
Yes, sir.
So then secondary valencies were present inside the coordination state.
Coordination number.
And
Okay.
those were the ionizable primary ones.
Primary valency.
Counter ions. Those counter ions were there. Now we have to mention the oxidation. If, for example, if you are saying for some of the examples which you have taken, if you are saying cobalt is in 2 oxidation states, you have to write like this. Platinum 4, how will you write? Roman letters. These are the Roman letters they are used, student, to write the oxidation states of these. This is my 2, 3, and 1, 3 is lot of metals are existing in +3 oxidation state. These are all transition elements, you know about it.
Yes, sir.
So +2, +3 most common oxidation states, or the 3D series, the elements which we are talking. Okay, that we have to work it out and then write it. So you have chromium 3. Further, student, if the complex ion is a cation, complex ion cation means what? It will be coming before. Complex ion cation means it will be coming just like potassium. So if complex ion is a cation, student, what will happen? Then the metal is named same as the element. The
Okay.
name of the metal does not change. Cobalt is cobalt, chromium is chromium, iron is iron. All the elements are named accordingly. Is called cobalt and platinum is called platinum. If complex ion is anion, now here the story starts. If complex ion is an anion, student, the name of the metal ends with the suffix ate. If it is an anion, what I will do? It will be ate. So cobalt in a complex anion. This is a 2 minus anion. This is anionic complex.
Yes, sir.
Anionic complex. Cobalt is anionic. So here it is not cobalt, it is cobaltate.
Okay.
Put ATE. ATE will be put, student. ATE will be put where you will have anionic complex. So the certain metals, I will tell you, there are some Latin names given to them.
Okay.
We have to remember that. For few, I will give a list. Lead, how will I write lead, student? Leadate, never written. The Latin word for lead was plumbus. So from they make plumbate.
Okay.
Iron, iron,
Ferrate.
iron is not written as irate. It is written
It's
as
ferrate.
ferrous. Ferrous was the Greek Latin name, and they make it ferrate.
Okay.
Gold, gold is Orus was the name of the gold, orate. So that list we will give you. We have to see whether it is an anionic or a cationic ligand. Anionic complex, anionic complex ion, student. The last letter will end with for the metal atom ATE. And if it is neutral or cation, then the same name will be used. Same name will be used. Okay?
Yes, sir.
So this is the way we have to learn it. The neutral complex molecule is named similar to that of the complex cation. There are neutral compounds which we have given you, they will be named similar. For example, see here when I write this one neutral, any charge here,
No, sir.
any cation or any anion, can you see? Nothing.
No, sir.
So it will behave like a cation, named
Okay.
named like a cation. Tetracarbonyl nickel, I have not changed anything. Nickel as it is, nickel as it is, and then the oxidation number of the nickel has been written. Oxidation number of the nickel has been written, students. Therefore, students, let me give you something more, because which I will be using. I have to see the information is required. All right, see here, I have got a list of anionic ligands, students. This was also used. Now they are using bromido.
Yes, sir.
This is also not wrong. This is also accepted.
Okay.
Fluorido, fluorido, students. Negative anionic oxo. OH is called hydroxo. So now we are saying cyanido. In 204 IUPAC change this. Oxalato, even cyano is used. Oxalato, carbonato. You can note down, these names are important, student. They are going to be there in our questions. Some are very common. We have
Okay.
taken that. If you want a bigger list, it is given in the books. But at least those which are given in our books and are more likely to be asked, we should know about them.
Okay, sir.
Acetato, carbonato, oxalato we use a lot, student. Oxalato, and sometimes you represented by OX. You know, OX I use. Amine is very important. Large compounds, large coordination compounds, you have ammonia. Water also you have so much aquated ions, coordination compounds. We should learn. NO nitrosyl, CO carbonyl. If I get oxygen is dioxygen, dinitrogen. This is pyridine. This is ethylene diamine. This En we represent by En. There is a long list of this. There is no end. But we have taken some of that. Interested students can see more bigger list of that. Okay? Further, students, I said key number of the ligands is important, which will be used as prefix. If the same ligand is there, if a ligand is coming only once, then you are saying mono, no problem. If the ligand is coming two times, die. But what happens? Where we use bis, students? If the ligand, if the ligand, itself has a numeral. For example, in ethylene diamine,
And diamine.
in oxalato. So if I have EDT, this is a hexadentate.
Yes, sir.
So what will be hexakis?
Okay.
So what we are using, bis, tris, tetrakis, 5 pentakis, otherwise penta, 5 ligands. But if it has a numeral in itself, within itself, then it is pentakis, hexakis. So I remember by kiss. This is also kiss, tris, vis. So they are made from kiss, students, these names.
Okay.
Okay. These are just to learn, students. Learn. Okay. We can learn them. That is my
Okay.
point. Further, more information, students. See, certain metals, I said, they will be special when they will be in the anionic complex. What I said, what was the rule for anionic complexes? If the complex is anionic, then the last letter should be
8.
for the metal atom. If it is cation or neutral complex,
Same name. It will be same name as that of metal.
complex, then the metal name remains the same.
Same.
Metal atom name remains the same. This is a very important point to be noted for writing the IUPAC naming, students. देखो, these letters I said, they are, we have seen where they are taken from, the letters which we said. Roman letters were there. Iron was called ferrous. So ferrous is converted into
Ferrate.
copper. Copper,
Cuprate.
copper is cuprate. They were like cuprous. Now lead was plumbous. So it is converted into plumbate. Argentinus, argentate, student. Gold is important because it's something very different. Gold, orate, orate. Tin, tin also stannate. See, these are totally different. Rest you are using nickelate, chromate, but here we are not using that. So these names should be known to us because they will come in the coordination nomenclature. Okay, you have noted down this.
Yes, sir.
All right. This was some list, students, which we wanted to tell you that this is a scheme of how do we name these compounds, student, how to name the compounds. There will be a lot of questions based on this, students. For example, students, the question is on the screen for us to solve now. Question 1. We have learned the rules. We don't remember all of it yet because we have not solved any question. We have not solved any question. In this complex, student, in this complex, what type of complex is this? Cationic or anionic? First question. Tell me. Is it a cationic complex or anionic complex? First thing, tell me, student. What do you mean by cationic complex? Does it have positive charge or negative charge?
Sir, it has a positive charge.
Wait a minute. If I have doubt, I will write down. See, I have to work out, student. No hurry. Once I understand, it will be easy for me. Otherwise, I will be confused. This is the cationic part. This is the anionic part. Yes or no?
Yes, sir.
First part
Yes,
is
sir.
the cationic part. How
Cationic
much is
part.
the charge? 3 plus and
3
3
plus
Cl minus.
minus.
This is a cationic complex. First thing I know.
Yes, sir.
In the rule, he has said if it is a cationic complex, then what will be the name of those? Cationic complex. Okay. First thing we know. Now, in the naming, students, what I said, ligands are named first.
Yes, sir.
Ligands are named first, you are saying. You are saying ligands are named first, prefix. Okay?
Yes,
Then
sir.
will come the metal,
Metal.
metal atom or ion. Is that a rule? Yes or no?
Yes, sir.
Alphabetically. Alphabetically. I'm just working out on my rough sheet. Alphabetically, tell me which are the ligands here.
Amine and aqua.
Let me name them. What is the name I told you for H2O?
Aqua.
Aqua. Spelling should be checked, student. I have
AQUA.
for certain I have given specially because they will be repeatedly asked in the paper. What is the next one?
Amine.
Amine.
AMMINE.
Okay, which is alphabetically first?
Amine.
M comes first. A and A are same. Then next one. Okay.
Yes, sir.
This is at first priority is amine. How many are these?
3.
Three. So what we use? Try.
Triamine.
How many are aqua?
Triaqua.
Try aqua. Okay. All right. This we have worked out. Number one, number two. ठीक है?
Yes, sir.
And students, what is the oxidation number of chromium?
+3.
We have to calculate
Yes, sir.
oxidation state. I am not hurry up. I am not hurrying up. I can hurry up if I am so confident. I am not. Let me tell you X, chromium X, ammonia
0.
3 into 0 plus 3 into
0.
0. ठीक है?
Yes, sir.
And then you have minus 3 Cl
-3.
1 equal to 0. ठीक है?
Yes, sir.
So what is the answer then?
3.
0, 0. X is equal to plus 3. ठीक है?
Yes, sir.
Okay. The oxidation number is plus 3. How do we write in Roman letter? 1, 2, and 3. ठीक है?
Yes, sir.
This is a cationic ligand. Then whether the name will be chromium or chromate, tell me.
Chromium.
Chromium. Okay. Once I know all this, I will be fast in the exam, no problem. But I should know how I am doing it. Okay, then give me the name of this. First one, which will be what?
H2 and H2.
What are the rules?
This will be,
The
first
rules.
of all, cationic complex है सबसे पहले.
What is the first letter?
This is
Am I right or wrong? I can be wrong also. Check me. On the rules, whatever rules we have, if I violate the rule, I will be wrong. Alphabetically, I have to name the ligands first.
Yes, sir.
That is amine comes first, aqua comes second. Triamine, triaqua. Triamine, triaqua. Then the metal. This is a cationic complex.
Yes, sir.
Chromium. Then I write the oxidation state of chromium. 1, 2, 3. ठीक है?
Okay.
Now the last is Cl3. ठीक है?
Yes, sir.
I only write student what I write.
Chloride. Chloride.
That's all. Because when I will write the formula of this, then I will use those.
Yes, sir.
So I am not writing trichloride. Those which are outside or before, they are never written dipotassium or tripotassium if it is before. Right? So they are only written once. Here, ligands are written tri, di, tetra, but these are not written. Clear? Is it any doubt, students?
No, sir.
Okay, I am giving another question. Another question. How did I work out? Is it cationic or anionic ligand? First point.
Sir, second one is a cationic complex.
Cationic complex. It is a cationic complex, student. That means what you are saying, you have CO, NH2, CH2, CH2 NH2
NH2
twi- uh,
whole 3.
three times, three times, ठीक है,
Yes, sir.
and twice SO4
4
three
whole
times,
3.
three times.
Yes, sir.
So this is positive. If I write 2, it is 2, then what is it? 3 SO4 2 minus, then what is the charge? If this is 2 times, this will be 3 plus.
Yes, sir.
This charge will go here, this will go here. We know this is what is mean 3 SO4 2 minus.
Yes, sir.
And what will be this? 2 times of this
2 times
and 3 plus charge. 3 plus charge. What is the charge on that? 3 plus.
3 plus.
So in this only one ligand is there, students.
Yes, sir.
What type of ligand is this? This type, this is ethylene diamine. It
Yes, sir.
already has a number 2 in it.
So it will be trace.
So we start this with what will we do then? We have to use trace,
Trace.
trace, trace. If I ethylene diamine we can write, or ethane 1,2
Ethane
diamine,
1,2-diamine.
or ethylene diamine also I can use, no problem. We because it's given in the book there. Okay, if you want to use ethane,
1,2-diamine.
ethane students, 1
1,2-diamine.
2 di amine, 1 2 di amine,
And
ethane
3
1 2 di amine student. Whether it will be,
plus 5.
what will be the name of the metal here?
Cobalt.
Cobalt. I am not used cobaltate, cobalt, because it's cationic complex. It is cationic complex. Cobalt. Then what is the oxidation number of cobalt? We have to calculate. Oxidation number of cobalt, students. Calculate oxidation number of cobalt. In this case, student, what it looks like, it is, if I split up, I am writing now in short form. Okay? What was the charge coming? 3 plus.
Yes, sir.
Okay?
Yes, sir.
So it is clear. There is nothing. This is x
It will be 3 only.
into 0 is equal to plus 3. So cobalt is
Cobalt 3.
3. And what do I write in the end, student?
Sulfate.
Sulfate. That's all.
Yes, sir.
Okay. So this is a how we name them, student. This is how we name them. This is important point. Important point, students. And another example we have taken is, student. Now here there are, this is also complex. So this is also complex. The first one should be cation,
Yes, sir.
and second one should be anion.
Anion.
Cation and anion. So cationic part and anionic part, students. So how do I separate cationic and anionic parts? Supposing silver, you are aware of silver, students. What is the oxidation state of silver? +1.
+1.
So I may split it like this. This is
Diamine.
cationic, this is anionic. And now you
Yes,
can
sir.
find what is the oxidation number of Ag here.
+1.
What is the oxidation number of Ag here?
It will be cyanide is minus, no? So x minus 2 to minus 1. +1 only.
Okay, both are 1 1. Both are 1 1.
Yes, sir.
So how will I name? What is the name? This is NH3. First cation is named. First cation is named.
So diamine.
Diamine. Diamine. Now this is a cation.
Yes, sir.
What will be the name of then?
Silver.
Silver. Oxidation state
1.
1. Further, what is this?
It will be dicyanide.
Dicyanide, or cyano also we can use. Dicyanide. And now what is the name of Ag? I told you.
Ag here it will be arginate.
Or we have to check the spelling now. In the table we gave that argentate,
Yes, sir.
argentate student spelling we have to be careful. And oxidation state is again one. ठीक है?
Yes,
Is
sir.
it any? Did I do any wrong?
No, sir.
Okay. All right, students, that this is a way to name these compounds. We will continue and ask more questions on this in our next class. So you can see that a question is coming on this, and it will need lot of practice in
Yes,
order
sir.
to get, yeah, marks from this. And one question is 100% coming, so we cannot ignore it. Then I will meet you in my next class. Okay, students,
Okay, thank you, sir.
good night.
Okay, thank you, sir.